beloved students. Welcome back again to our FB Live in Science 8. So last time, we discussed all about the speed of sound, especially or specifically the effect of temperature on the speed of sound. And I know you learned a lot from those topics. So for now, we will be discussing about light, heat, and temperature in the unit 1 of our module, which is sound, light, and heat. We are done discussing about the speed of sound. And for this morning, we will be discussing about light, heat, and temperature. Are you ready? Okay, let's start. Our objectives for this morning are, first, explain the hierarchy of colors in relation to the energy of visible light. And our next objective is differentiate between heat and temperature at the molecular level. So do not forget these two objectives that we need to reach, okay? Or we need to target, or we need to explain this morning. So you need to complete the following word or words in relation to our topic. So I know you are familiar with these words. So are you ready, class? Okay, let's start. Our first word is this. Timer starts now. That is very easy for you. You need to complete the word or the letters of the word so that you can know the final answer. Time's up. The correct answer is none other than light. Okay. Next, how about these words? Timer starts now. You already tackled that way back in your grade 7. Okay, time's up. The correct answer would be, anyone? Okay, that is electromagnetic spectrum. Correct. How about this next word? Four, three, two, one. Time's up. I know you guessed this word, and the answer would be exactly, that is heat. How about this next word? Three, two, one, zero. Time's up. Okay, you need to type your answer on the comment section, and the answer would be, that is wavelength. Okay, correct. How about this last word? Okay, last word for you, class. Go, type now your answer on the comment section. One, zero, time's up. The correct answer will be, that is thermometer. Correct. Now, class, I know you are familiar with those words that I showed to you on this slide. And let's go now to the facts of light. Okay? So there are 3 facts that you need to know in this slide or in this topic. So first, light travels much faster than sound. Example of this class is the thunder and then the lightning. You see the light in the lightning, and after that you hear the sound from thunder. Okay? Next, aside from this, facts is this. We see things because they reflect light into our eyes. Okay? It is because of the light, okay, that we can see things. Without light, we cannot see things, class. Okay? And last but not the least is shadows are formed when light is blocked by an object. Do not forget this. Example of this is, if this is the sun, okay, and this is the things, okay, and these things block the sun, okay, it forms shadows at the back, okay, so do not forget that class. Now, after that, we will be defining, or we will be discussing the meaning of light. So, the question here is, what do we mean by light? I know some of you are wondering, you know about the light, but what really is the meaning of the light? So first, when we say light, it is a wave or rather acts like a wave. So when we say wave, class, last time we talked about that wave. Am I right? I know you are familiar with that word, wave. So when we say wave, the meaning of this is a disturbance, okay, or variation on which the sound travels through a medium. Actually, that is the wave. The word disturbance. Okay, do not forget that. Aside from this, another meaning of light is a special type of wave. Okay? Do not forget these highlighted words. It is a special type of wave. And last but not the least, what we know as light or visible light is actually a type of something called electromagnetic radiation. Okay? So ano you are familiar with those words such as electromagnetic radiation? And now, we will be defining the meaning of electromagnetic radiation as well as the electromagnetic waves. Let us define first the meaning of electromagnetic radiation. So the question here is, what is electromagnetic radiation and what is electromagnetic waves? So do not forget this question. Both of these two are quite different from each other, but they have the same when it comes to what is so-called electromagnetic. Okay? Actually, class, when we say electromagnetic radiation or EMR, it refers to the waves of the electromagnetic field propagating through space carrying electromagnetic radiant energy. So have you seen the electromagnetic radiant energy? This electromagnetic radiation is a form of energy, especially or specifically the radiant energy. Now, I want you to remember these words. When we say electromagnetic radiation, class, it is propagating through space. When we say propagating, okay, it means to transmit radiation from one location to another. Okay, so that's what you call propagating through space, electromagnetic radiation. How about electromagnetic waves? When we say electromagnetic waves, these are the waves that are created as a result of vibrations between an electric field and magnetic field. So it is between electric field and then the magnetic field. When it combines, it resulted vibration. That's why it is known as electromagnetic waves. From the word waves again. Okay, disturbance. Okay, so there is a vibration, result of vibration. That's why it is created. Okay. Now, aside from that, we need also to define the meaning of electromagnetic spectrum. I know you are familiar with electromagnetic spectrum. Okay? When we say electromagnetic spectrum, it is the entire range of electromagnetic waves arranged according to their frequency and wavelengths. So, in this electromagnetic spectrum, I want you to remember the highlighted words such as range of electromagnetic waves. And for you to be able to understand it clearly, I have here a photo or picture of electromagnetic spectrum. And inside of electromagnetic spectrum, class, is what is so-called electromagnetic waves. That's why in electromagnetic spectrum, it is the entire range. Okay, as you notice, I highlighted these words such as gamma rays, X-rays, up to radio waves. Actually, those are the 7 types of electromagnetic waves. Okay, and as you notice, class, there's on the mid part is a visible light. Actually, another fact is this: visible light is the only that we can see. Okay, we cannot see the gamma rays, X-rays, etc. Okay, now as you notice, we need to define first the meaning of visible light. Okay, what is visible light, sir? Visible light is all of the colors of light arranged in order according to their wavelengths. Such in Roy G. Biv class. Actually, these are the visible light, Roy G. Biv. Actually, there is a song here in Roy G. Biv. Way back in my elementary days, the song is this: red, orange, yellow, green, blue, indigo, and violet. Have you encountered that song, class? So do not forget that because I still remember that song. Okay? RGB stands for red, for R, or O, orange, yellow, green, blue, indigo, and violet. So that is red, orange, yellow, green, blue, indigo, and violet. So do not forget that song, class. Actually, I still enjoyed that song. Until now, I still remembered that song. So when we say visible light again, it is all of the colors of light arranged in order to their wavelengths. So do not forget that, class, according to their wavelengths. And when we say wavelengths, class, it is the distance from crest to crest of the wave, or from trough to trough of the wave. Okay? So I know you are good in reviewing or recalling those things. Now, we will go now to this picture. As you notice, class, if you focus on this picture, on this part, on that end, the colors, okay, the color, such as the red up to violet, actually, it has something to do with the wavelength and then the frequency, as well as the energy. Now, I want you to take note of this, class. From red, okay, up to violet, actually, if you notice the wavelength, it is measured in nanometer. Okay? It is measured in nanometer. Okay, the shortest, the wavelength, it is the greatest energy. That's why the violet has the highest photon energy here in our topic. So do not forget this. How about, sir, the frequency? Frequency, actually, there is a directly proportional relationship. Okay? As the wavelength shortest, the energy of or the frequency itself also has the highest. Okay? So do not forget this. Aside from this, I have here the range of electromagnetic waves. Okay? Those are the color. From violet, this one, from violet, okay, the measure of the wavelength is this. Okay? How about in red? In red, the wavelength of this red color is this. Okay? So do not forget this, class, because we need to focus on the hierarchy of colors. Do you still remember our objectives? Okay? Explain the hierarchy of colors in relation to the energy of visible light. Okay? So each color, class, has its own energy, frequency, and wavelengths. Okay? So do not forget that thing. Aside from that, I prepared here the for you to be able to understand it easily. I prepared here the wavelengths as well as the measurement, okay, in nanometer. Okay? Actually, when we say nanometer, 1 billion of a meter, class. Okay? Now, aside from this, as you notice, from red up to violet, okay, up to violet, from large, okay, from higher number to lower number. So when we say this one, from higher to lower, means the higher the number, the measurement of wavelength, okay, the lower the energy. Okay, the slower the energy. So do not forget this. Now, the only thing that we can see on the 7 types of electromagnetic waves is none other than visible light. Another fact is this: when we combine all the colors from red, okay, from red up to violet, plus, actually, we can produce what we so-called white light. Okay, white light. Okay, puti in Tagalog. Okay, white light. Now, aside from this, okay, we need to focus on this thing. Remember this thing, class. Do not forget this with regard to the topic of colors of light. Okay, remember this. All wavelengths of light move at the same speed, but different wavelengths have different energy. So I highlighted those words. May I repeat for the last time? All, as in all means all. All wavelengths of light move at the same speed, but different, okay, wavelengths have different energy. Okay, different wavelengths has its own different energy. Okay? For example is the color red. Example, color red, the wavelength of color red is quite different from the color of the wavelength of violet. Okay? So they have all wavelengths actually have the same speed, but they only differ on the wavelengths as well as the energy of wavelengths. Okay? Do you still remember that? Or can you cope now the discussion? Okay? So we go now to heat and temperature. I know you don't have any question with regards to colors of light, but if you have question, you need to write it down or type it on the comment section. Now, as you notice on the picture, I have here the picture of heat and picture of what is called temperature. Now, some of us quite wondering about, sir, is there any difference between heat and temperature? Actually, class, yes, there is a difference between them. But actually, some of Filipino or some people are thinking that both heat and temperature are quite the same. Okay? Now, we have all noticed that when you heat up something, its temperature rises. Okay, as you notice in this picture, as the when we heat up something, there's something with objects. Okay, as we heat it up, okay, the temperature also rises. Okay, as you notice on the picture, it moves from lowest to highest. Okay, now we think that heat and temperature are the same thing. As I said a while ago, some of you are quite wondering, sir, there's no difference between them. Okay? They are both the same. Actually, there is a big difference between them. But, according to this one, heat and temperature are related to each other but are different concepts. Actually, class, they are both quite related from each other but each of them has its own concept. Okay? Now, we all know that all matters are made up of molecules and atoms. And the motion of atoms and molecules creates heat or thermal energy. So, do not forget this. When we say atoms, combination of atoms, we produce molecules. Okay? So, in this thing, the motion of atoms and molecules creates heat or thermal energy. Sample of that class, if I rub my hands, it produces what is so-called heat energy or what is so-called thermal energy. Okay? Aside from this, all matter has this thermal energy. Okay, do not forget this. All matter has its own thermal energy. From potential kinetic energy to kinetic energy. Okay, that is the thermal energy. Now, moving forward, aside from this, we need to mention this one. The more motion the atoms or molecules have, the more heat or thermal energy they will have. Do not forget this. The more motion, okay, of atoms or molecules have, the more heat or thermal energy they will have. Okay? So do not forget these things. Now we need to define the meaning of heat and temperature. Okay? So when we say heat, class, it is the form of energy that is transferred between systems or objects with different temperature. It depends about to the object. Okay? With different temperature. That is it. Do not forget the terms form of energy. So, if it is energy class, what would be the unit? What would be the unit? The unit would be, exactly, the unit would be joule or Newton meter, discussed by Sir JC. Okay? Aside from this, how about temperature? Temperature, it is the degree of hotness or coldness measured on a definite scale. Okay, so do not forget the meaning of this one. Heat, form of energy measured in joule, while temperature, degree of hotness or coldness. Okay? Measured on a definite scale. Measured in degree Celsius, degree Fahrenheit, Kelvin, or another thing is Rankine. Okay? Now, aside from this class, we need to have this picture to analyze this picture. On this picture, we have the temperature, how hot or cold that object is, while the heat is transferred to the object. Example is stove, heat pan. Okay? So as you notice, the red part, okay, this is the heat coming from stove, while this one, temperature is came from the thing. Okay? Came from the thing or object. Okay? Which is heated. Now, aside from that class, I prepared another photo for you. So when we say heat, the heat energy from the stove, so burner warms up the water. While this one, the temperature or the thermometer measures the temperature of the water. Okay? As you notice, as the heat rises, the temperature also rises. Now, as you notice, the boiling water is 212 degrees Fahrenheit. Or in Celsius, that is 100 degrees Celsius. Okay? It measures the heat. Okay? So do not forget, as the heat rises, also the temperature rises. Okay? Now, aside from that, we have this slide. So heat is the transfer of thermal energy, whereas temperature is a property the objects or object exhibits. Okay? So do not forget this. It is the heat which transfer or thermal energy from one object to another object, and the temperature itself is the property or the object which exhibits. Okay? Do not forget those things. And aside from that, I have here the another information of heat. Okay? Heat measures how energy moves or flows. Okay? As I've showed a while ago on the picture, it is energy that moves or flows, the heat. Okay? Aside from this, an object can gain heat or lose heat, but it cannot have heat per se. Okay? An object can gain. Okay? It can gain heat or lose heat, but the object per se cannot have its own heat itself. Okay? So do not forget that. They need interaction. Okay? Now, aside from this, I have here the chart, basis comparison of heat and temperature. Okay? So when we say comparison, first is the meaning. When we say heat is the amount of energy to a body. When we say temperature, it's the it is the measure of the definite or infinite of heat. Okay, so in measures, okay, as you notice, total kinetic and potential energy. While in the temperature class, it's the average kinetic energy. So as so on, as so forth. Okay, so now we go now to discuss some of these, such as the this one, working ability for heat, that is yes, and for temperature, that is no. And then when it comes to unit of measurement, that is in heat, again that is joule, while temperature, that is, what is that? Kelvin. Okay, another is degree Fahrenheit, degree Celsius, and then Rankine. And when it comes to the device that we are going to use, okay, from the heat is calorimeter, while the temperature is thermometer. While it labeled, the symbol for heat, it labeled as Q, and temperature, it labeled as capital T. Okay, capital T, it means temperature, not time. Now, we need to differentiate the two. Okay? The final word is this. The core difference is that heat deals with thermal energy, whereas temperature class is more concerned with molecular kinetic energy. So do not forget the difference between the two. Okay? heat deals with thermal energy, while the temperature concerned in molecular kinetic energy. So do you have any question, class, regarding that? Regarding the colors of light and also regarding on the heat and temperature. And we go now to the question and answer portion. Okay? So in question and answer portion, I prepared here 3 questions for you. Number 1 is this. What is the importance of knowing the hierarchy of colors in relation to the energy of visible light? Is there any importance, class, of knowing the hierarchy of colors in relation to the energy of visible light? Yes, of course. There is a big importance of knowing the hierarchy of colors in relation to the energy of visible light. Because sample of this is color red. Okay? We can have the wavelength and then the frequency of this. And then, if we compare it to the highest, which is violet color, this is slower, the red one. Okay? So, we need to know the hierarchy of colors, class, in order for us to know what color, what wavelength, or what frequency does this color exhibited. Okay? So, we need to know that from lowest to highest. Actually, class, some of the film or movies are using the green color. Do you know what's the reason behind that? Okay? That is your assignment. Okay? Now, aside from that, second question is this. How do we explain the relationship between wavelength and frequency? Is there any relationship between them? Of course, yes. There is a big relationship between them. Wavelength and frequency, as the wavelength, okay, as shortest wavelength, we have the higher frequency. Okay, actually, sorry, I'm wrong with that thing. When shortest wavelength, class, has the highest energy, frequency is quite different from wavelength, because higher wavelength has the slower frequency. Okay? Do not forget that, class. Actually, they are both inversely proportional from each other. So that's the correct terms, class. Inversely proportional, both of them, wavelength and frequency. Now, aside from those questions, why do we need to differentiate heat from temperature? We need to differentiate heat from temperature, class. Because some of us, okay, some of the people are quite, what do you call this one? Ambiguous when it comes to heat and temperature. Actually, they are quite related, but they have different concepts. We need to differentiate both of them because each of them has its own property. For example, in temperature, it has own property. When the heat, it is only for the thermal energy. We cannot gain heat, class. Okay? We cannot have our own heat. Okay? But we can gain or lose heat. Okay? These two terms are directly proportional. As the heat rises, the temperature also rises. Okay? So I know you learned a lot from this topic. So that's all for today, class. We need to end and you need to focus now for the next module. So thank you and God bless. Bye. Do not forget also to like, share, and subscribe my channel. Click the subscription button and my pranks. So if you want to laugh, just watch my pranks. And also, hindi lamang yan, ginawa ko po itong video. It is because for this reason. Next one is study and meditate the genuine gospel. So let us spread the gospel of Christ in this mid of crisis. So do not forget again to subscribe my channel Phaully TV or Teacher Phaully TV.